Hello, this is Scott Ayler. I'm Corporate Vice President and General Manager of the Data Center Solutions Group here at AMD, and very excited to be here with you and tell you about our next generation Epyc second generation server processor. It all started in 2017 when Epyc announced our first generation Epyc and really ushered in a newer era in the data center. With the first generation Epyc, our ambition that we achieved was to achieve performance leadership at every competitive price point. And we did that by bringing to market leadership features and capabilities, more cores, more memory, more bandwidth, and more I/O. And what this allowed our customers and partners to do was really achieve a superior total cost of ownership. And we built a tremendous amount of momentum along the way. In the past 18 months, AMD has delivered in the cloud, on-prem, and an exascale. When you look at the number of OEM platforms that we have in the market, from the best of breed partners, leaders in the industry with over 60 AMD Epyc platforms in the market, we're very proud of the momentum that we've established with OEMs and ODMs. But that's not all. We see tremendous momentum with the cloud players as well, with over 50 different AMD Epyc cloud offerings between instance types and different tier 2 service providers. AMD is well represented in the cloud. We also see that we're painting a path to the future. Epyc has been chosen as the exascale leader by being awarded the Frontier supercomputer in concert and conjunction in a partnership with Cray, which means that AMD Epyc technology and AMD Radeon Instinct technology will actually power the highest performance supercomputer in the world at 1.5 exaflops when it is brought to market. So tremendous momentum indeed. But we're here to talk about the momentum that we see today by bringing Epyc second generation to market. We aim to establish a new standard in the modern data center with second generation Epyc technology. We do this by bringing a new leadership architecture that allows for scalability, performance in ways that have not been seen before. We deliver that performance in terms of raw performance from an absolute perspective, but also a leadership price performance as well. We also continue on the strong momentum that we have from a security foundation, bringing more advanced security features to market. We're very excited to be announcing the AMD Infinity architecture. This takes the leadership capabilities that we established in first generation and really moves them dramatically forward on every major dimension. So looking from a performance perspective, we leverage the strength that we have from an x86 architecture perspective in the broadest ecosystem in the market, and we then drive performance with the advancements that we have in the new Zen 2 core. From an efficiency perspective, we take the multi-die approach that we had in the first generation, and we now pivot that to a hybrid multi-die approach. That means that we get the best IP and the best process and really deliver leadership performance and efficiency along the way. From a security perspective, we've had tremendous acceptance around our secure memory encryption and our secure encrypted virtualization, but we've enhanced the capability of those features in the second generation Epyc technology. And then finally, helping unlock system level bottleneck by dramatically improving throughput, taking the leadership 128 lanes of I/O and then moving those to the next generation PCI Gen 4 technology allows our partners, cloud providers, our OEMs and our ODMs to build new capabilities and unlock system level performance. So let's dig into each of these. First, at the heart of Epyc second generation is Zen 2. This technology has been built on 7 nanometer and allows us to achieve double the density over and above our prior generation. This means that we have the ability to pack in more cores, more cache, more performance. And that means that we can deliver more frequency at the same power or keep the performance the same and deliver half the power. Very tremendous flexibility in this technology that allows us to bring different offerings to the market. How did we then take and instantiate that 7 nanometer? We took and built in leadership capabilities from a Zen 2 perspective by delivering over 15% higher instructions per clock. We did this through a combination of improvements with regards to branch prediction. We've improved the throughput from an integer capability. We've doubled the vector width, which means that we have double the floating point capability over and above our prior generation. And we've also improved latency to ensure that we're able to feed all these high performance compute units and deliver true performance without bottlenecks. When you look at taking that technology from Zen 2 and 7 nanometer and packing it into the features that matter to our customers. So think about our leadership position that we had in Epyc first generation. From a core perspective, that only gets stronger by doubling the cores generation on generation. We had a very strong position in terms of I/O leadership with Epyc first gen. We now take and move that to the next generation Gen 4 and double the bandwidth in the fabric in the process. We continue the momentum around leadership memory bandwidth, extending that to 45% memory bandwidth advantage over above our competitors. We've talked about the security features, and again, we do this in a very simple and powerful processor stack. So we're very excited to be bringing to market the world's first 7 nanometer CPU at double the performance per socket of our prior generation, and ushering in the new standard in the data center with Epyc Gen 2. So thinking about how have we improved security over and above the first generation, we see threats across the board, across government, academia, in e-commerce. There's new attack vectors constantly coming to bear, and the business context and consequences of these breaches are very real, with millions of dollars compromised every time security is breached or compromised. And Epyc second generation really brings to bear advanced security features by allowing, with our secure root of trust technology, the ability to have a secure boot. You know that the firmware that is built into every Epyc is the firmware that was intended to run, and doesn't have malware or other kind of variants in it that would allow for security breaches potentially down the road. Secure memory encryption. This means that we can kind of essentially encrypt the entire system memory through a BIOS update that allows customers to feel very comfortable that what is living in memory is fully encrypted. And then finally, secure encrypted virtualization. This takes encryption to the virtual machine level. It means that each virtual machine is cryptographically isolated from each other, and we've expanded the capacity on this over first-gen Epyc to have up to 509 different instantiations of SEV on a single Epyc Gen 2 processor. So how did we do it? Thinking about with first generation Epyc, we introduced chiplets. So we had the idea that we have 4 different die in the first generation Epyc. This allowed us to put the most silicon in the socket. Multiple smaller die allowed us to have an inherent yield advantage, which meant that we could drive performance and cost up without compromise, and gave us tremendous configurability and the ability to take this die and leverage it across many different product types and product families. Now, we've evolved that in Epyc second generation. So we've taken this chiplet philosophy of identical chiplet was first generation Epyc that you see in the middle here, and we've now migrated that to second generation Epyc. So we have a unique 14 nanometer I/O die in the center, where all of the DDR, the I/O is all centralized. We then kind of surround that with up to 7 nanometer CCD chiplets that have the core and cache. And the reason why we've done that is it really allows us to have a very strong density from a CPU perspective and leverage the goodness that is 7 nanometer technology. Very efficient implementation. This also, beyond the inherent performance and cost advantages, drives a much simpler NUMA domain architecture, which means it's easier for our customers and partners to leverage in their software infrastructure. But it's not enough to have that unique architecture within the device if you can't feed it. We've actually now advanced our memory speed and memory bandwidth over and above the first gen. And what you see is that by moving our DDR speeds to 3200, we have a 45% memory bandwidth advantage over and above our recently released competition. Finally, thinking about the Infinity Fabric, which is really kind of the glue that holds all of this different technology together between sockets within the architecture itself, we've really up-leveled the performance in the Infinity Fabric. We have 4 links that allow for leadership socket-to-socket bandwidth capability and very efficient connections to external devices off chip. We've definitely provisioned and delivered bandwidth for performance scaling with the new Infinity Fabric. We've talked about the ability to usher in, kind of leadership I/O with PCI Gen 4. This really takes and unconstrains things at the system level. We double the bandwidth per channel. We dramatically improve accelerator performance. Things like drives, things like network cards, things like GPUs that are starved for data. PCI Gen 4 doubles the data rate and makes those operations to those peripherals even more efficient. At the heart of our security implementation is AMD Secure Processor. It's the hardware root of trust that provides the foundation for our platform security and manages all of the keys, all of the security features to ensure that the security that lives in Epyc is robust. Looking at the 7002 series processor at a glance, we have up to 64 cores, double over what we had in the prior generation. We've doubled the cache, which is very important to deliver leadership performance. We've reduced the NUMA domains, as I talked about before, with this centralized I/O capability. We support all of the latest memory standards, and we have the capability to address up to 4 terabytes per socket. Really leadership capability and performance at the SoC level. So how do we think about delivering and bringing this processor technology to bear in workloads and verticals where that performance is needed? So whether it's HPC, whether it's the cloud, machine intelligence, things like Hadoop, things like hyperconverged infrastructure, we're very focused on delivering high performance across these workloads that are growing, that continue to need more compute. And we're going to take and map those technologies to the right applications. The other thing that you see from AMD is we have a very strong focus on an open ecosystem, which means that we don't use proprietary technologies or proprietary compilers. We open source things. That means that we give people and customers the ability to innovate. And this is an important thing to keep advancing the industry moving forward. I talked about the simplicity of the stack, but when you look, one of the unique features that we have in Epyc second generation, building on the momentum from first gen, is we have feature parity in every device that is in the AMD product stack, whether it's our 8-core entry-level devices all the way to the top of stack 64-core products. We have an identical footprint in terms of memory channels, in terms of memory support, I/O capability, features that matter like security. You don't have to compromise on features if you're just looking for performance. This is a very powerful and simple capability that enables our partners and customers. It's not enough to have a great technology if you don't have a robust ecosystem, and we've made fantastic progress over and above Epyc first gen by bringing the best of breed hardware partners in the market, leaders in memory and drives and peripherals that all have day one ecosystem support with Epyc. Looking at it from a software perspective, the OSs, looking at features that are very relevant, like SEV, like secure encrypted virtualization. We've done fantastic work across Linux, across Windows, across VMware to ensure that we have terrific day one support for those leadership security features. And the application ecosystem, whether it's cloud, whether it's HPC, whether it's the enterprise, has definitely grown and is super robust coming out of the chute with Epyc second generation. So hopefully you see from this that we've made tremendous progress, and we're very excited to be bringing Epyc second generation to market. And we truly think that the modern data center is Epyc.